We all know that one friend who gets into fighting games because of external factors beyond the core gameplay. Things like a really cool art style or quite literally the best soundtrack to ever accompany a video game. But then as they start to play the game, they realize, oh, I actually suck, and that Smash Bros is completely different to traditional fighting games. But then they realize, hey, maybe it's not me. Maybe it's the controller. So they look at all the pros and then they see, oh, they're all using FightPads and sticks. So now you gotta look into getting one of those. Well, I know that friend because he's me. However, I'm not gonna be buying any normal FightPad like a scrub. Oh no. We're building our own, baby, with a little bit of electronic know-how and some 3D printing. Also, a big shout out to PCBWay for sponsoring this project. More on them later. See, I really like Guilty Gear Strive. Just one problem. I kind of really suck at Guilty Gear Strive. See, I'm pretty good at Smash Bros, but when it comes to traditional fighters, I just can't seem to pick them up. But what if it's not me? What if it's this stupid DualShock layout that I've been using that's making me get my ass handed to me by bots?
Yeah, I know, it's definitely me.
But I still think it'd be really cool if I tried to make my own FightPad, cater to my own hands and style. So there are a few styles and layouts of FightPads that you can get right now. There's the fight stick with buttons, there's the all button one, and the hitbox style. And to me, hitbox style is definitely my favorite. It just seems the most comfortable and it looks the coolest in my opinion. So I got a piece of paper and sketched out roughly where I wanted the switches to go. I want 16 buttons with a good amount of space between the keys, so it's not going to be compact. And I'm actually going to be using MX style key switches for this board, solely because I have leftover Akko creamy switches and they just sound so nice and docky. And then all the switches are going to be connected to a Raspberry Pi Pico. Why a Pico? Solely because it looked cool and it was accessible to me. Yeah, a Pico is technically overkill for this project because I have 16 buttons when a Pico has 28 GPIO pins and 40 pins in total, so it's kind of too big for what I need to do, but I just like the look of it. So after taking the time to sketch out a layout, I finally had to make a choice. You see, there's two ways you can make what is essentially a keyboard in my case, and that's using hand wiring or PCB. So hand wiring is when you wire all the switches by hand. Wow, who would have guessed that? While this option allows for more freedom to get creative with the design and layout, to me it's just kind of a pain in the ass and super tedious all around. However, using a PCB or a printed circuit board is way easier, with the main drawback being you're limited to the second dimension. But most of the time you can always finagle with connectors and stuff to achieve a wacky layout, kind of like with hand wiring, but at that point, just hand wire the whole thing. And so with either method, the wiring is all the same because a printed circuit board is just a bunch of wires on a piece of bread. Board. See, the mechanics behind a mechanical keyboard are mechanically simple. Basically what you need to do is you lay out your switches in any arrangement that you want. These here represent the pins on the switches, and then right here is my Raspberry Pi Pico. So basically what you want to do is take all your switches and connect them in a matrix, which means that all of the rows and all of the individual columns will be connected. Pretty easy, right? So this is what your wiring is going to look like for the switches themselves, and then what you want to do is basically you just connect each of these rows and columns to a GPIO port. And so the microcontroller is always checking these rows and switches. So if you are pressing a switch, you are basically completing the circuit between that certain row and column, and it will know it's that certain switch. There's also some diode thrown in there to prevent ghosting and key blocking whenever you press multiple switches. But in its very simplest form, this is a mechanical keyboard. A 9-key mechanical keyboard, but still a mechanical keyboard. So which one am I going to pick? Well, do I want to take a long time wiring each single pin by hand and then making sure I don't accidentally short out anything on accident or make a wrong connection? Or do I want to spend a long time learning a new program to make my own PCB? And well, it's a difficult choice. See, well, that was pretty fast. Okay, so that took me about a few hours, but it was actually a lot easier than I thought. And that's because I lied to you earlier. See, you don't need a matrix when you have 16 buttons and a bunch of GPIO pins. You can just give each button a GPIO pin. Each switch is also connected to ground, so what the Pico does is that it just checks each of the IO pins, and if you're making a connection, then it knows you're pressing it. So this is actually one of the simplest PCBs you can make, really. But yeah, it was really fun and satisfying to do all the wiring for the PCB. Honestly, KiCad kind of feels like a video game. It's quite literally, where's my water? But instead of water, the alligator gets burnt out. I still have a lot more to learn with KiCad, and I hope for future projects they will be a lot more complicated. But for now, I'm pretty happy with what I got. So now it's time for me to find a way to make this PCB.
Yeah, this video is sponsored by PCBWay.
If you haven't heard about PCBWay, they are a PCB fabrication and manufacturing company that meets all your project needs. They make the process super simple, and with just a few clicks, you can get an instant quote on any product, whether that's a CNC or 3D printed part or a PCB. which is great for me because this is the first time I've actually designed something like this. Originally, I was actually going to hand wire my FightPad, but when PCBWay reached out to me, I just knew I had to learn how to design my own PCB. And so here we are. Again, big thank you to PCBWay for not only shedding me my first PCB design, but for also taking a chance on a small channel like mine. So let's get back to the video. Hi. All right, so now that the PCB is on its way, it's time to go into CAD and make the case for the actual electronics. And that's where KiCad really comes in clutch, because you can go ahead and take your PCB design, export that as a step file, and then, oh my god, this makes it so much easier to design in Fusion. And so this is the final design I came up with. I'll be honest, I kind of messed up with the PCB design because I designed it with through holes instead of hot swappable switches. And so when it comes to the design of the case, I either have to A, solder everything beforehand and put it into the case, or B, leave the back open so I can solder the electronics when it's in the case. And I went with option B. The case itself is pretty simple, and since I didn't want to use screws in this project, I just went ahead and made a dovetail connection for the back. And, you know, hopefully that works out. So it's time to get printing now that we have the case designed, but we do have a little bit of a problem. So I made this PCB to fit comfortably in my hand, obviously for ergonomics, and because of that, I had to make it a certain size, and unfortunately, that size is way too big to fit flat on the 256 by 256 3D printer. So I have to print it vertically and diagonal, which is not exactly optimal at all. But I went with it anyway, one, because I already ordered the PCBs, and it's a learning experience. I really like to learn by doing, so if I mess up, that's just a learning experience, and the future me can worry about that for the next product iteration. And trust me, this was a big learning experience. Yeah, it turns out a lot of my tolerances were wrong, so it took a few versions of the case to fit the PCB, and even then, it's still cracked. On top of that, since I'm printing vertically, there's no way for me to print a small section of the case to see if the PCB will fit. And so I had to print the case prototypes in their entirety, which is extremely wasteful. But at some point, I kind of got it all working. Okay, since I was changing the case tolerances and dimensions, the holes for the switches got misaligned, and now the switches sit on a lip. And I was thinking about scrapping this one, but I figured I could just use it as a prototype and start programming it. So I took it to my computer, learned a bit about CircuitPython, and a few hours later, it just works. You know, it's really cool to see something that you created come to fruition, especially when you do it the first time. Definitely did not mess up the code at all. But yeah, I finally got it working, and now I can finally see if I'm truly bad at Guilty Gear Strive. And I still am, who would have guessed? But although I may be bad at Guilty Gear, I think I'm pretty good when it comes to designing FightPads. But we aren't done yet. Yeah, even though this FightPad works, it kind of looks like crap. The keys are tilted, there's a huge crack in the side, and the back is too small and it comes off. Can you tell I'm not a professional? However, we are going to fix all of this using a special engineering technique called use the screws. Yeah, I don't know why I wanted to make this case fully 3D printed. My idea was to make it look like a one piece. Can we get much higher? So high. From the top. And I think I did achieve that along with the slimness. But then again, that slimness kind of made it hard to get all the electronics inside of this thing as well. So then I think it's time to redesign the case. Deja vu, I just been in this place before. Higher on the street, and I know it's my time to go. Going new, and the search is a mystery. Standing on my feet, it's so hard when I try to be me. Alright, so the redesign for the case is finished, and yes, I actually did make it that fast. I am just super quick when it comes to 3D modeling. So I decided to make this redesign two separate halves instead of the smaller backplate that goes in the back, just because it'd be a lot easier to insert these screws here, which I have 4 screw holes. And then you can see that the bottom plate has some space for all the pins for all the electronics. All right, so let's go ahead now and send both of these separate parts off to the 3D printer. All right, so the 2 parts are printed. Unfortunately, the warping is a big issue, and I kind of saw that coming after I saw how big I actually made the case. And so that is really my fault. I made the PCB way too big and didn't really consider how it would print. But hey, again, learning experience. So I think the next course of action should just be to completely redesign the whole project. But that's going to be for version 2. I am going to finish this project here because it doesn't look too bad. It it works. It fits. A few of the screws fit, but one of them is out of place, so it's not the most pretty thing. But again, it's gonna look fine. like the last version, it's gonna look fine from the front side, but the back side is gonna look a little weird. But I'm okay with that. So let's go ahead and get this thing started. All right, so the redesign is finished, and I'm actually pretty happy with how it turned out. Obviously, it isn't perfect, as I said earlier, because I'll be honest, I really didn't plan out this project well enough. However, for my first PCB project, I would say this looks pretty good. But it still won't make me good at Guilty Gear. So thanks again to PCBWay for sponsoring this project, and thanks to you for watching this video. So if you want to see version 2 of this board, or if you just want to see more maker and engineering content, then be sure to subscribe, because more of that will be definitely coming in the future. Thanks.